Hello, my name is Júlia Neves. I'm an undergraduate student from the School of Dentistry at the Federal University of Uberlândia, and I'll be presenting the in vitro study titled Photoprotective Capacity of UV Light of the Different Color Lids for 3D Printers. Initially, it is important to discuss digital flow in dentistry, which can be divided into three parts. CAI, computer-aided impressioning, that consists of acquiring the digital model. The model is then exported through three-dimensional files to a software of design, CAD, and imported through the manufacturing machine. Computer-aided manufacturing can be subtractive, with the use of milling machines, or additive, with the use of 3D printers. Additive manufacturing has been gaining market space within many professional fields, especially because of the equipment cost benefit, being financially more accessible than subtractive manufacturing. Furthermore, there is less waste of material, being a more sustainable workflow. The 3D printers and its complementary device, the post-curing unit, both work within the ultraviolet spectrum, emitting UV light to sensitize photoinitiators that vary the interaction range between 365 to 405 nanometer. That spectrum falls on the highest wavelength subdivision of the UV light, the UVA, and continues until the visible violet light. The major concern regarding UV radiation is the health risks documented throughout literature. The UVA is the most penetrating UV light, the only able to reach the endothelium, causing severe damage due to its cumulative aspect, with chronic exposure causing damage of eye and skin tissues, genetic mutations, and development of skin cancer, representing a work hazard to the operators that many times spend hours in a workspace with several 3D printing equipment. The purpose of the study was to evaluate the UV light photoprotective capacity of 5 3D printers anti-UV lids made in different colors. The materials and methods used were 5 photoprotective lids in the colors red, orange, yellow, green, and gray. Their thickness was measured with the use of a digital micrometer, making 5 measurements in different locations to evaluate the mean value. The light power was emitted through the post-curing unit washing curve 2.0 of n cubic and then measured through the intergetting sphere with 12.5 mm opening connected to a fiber optic spectrophotometer. 3 LEDs were randomly selected and stabilized using a printed support, perpendicularly to the opening of the intergetting sphere as shown in the photograph. The light unit was stabilized in position 0 mm from the intergetting sphere, as well to 2.9, the average thickness of the acrylic lids, and then with the interposition of each one with the LED touching its surface. The anti-UV lids used were in the color red, orange, yellow, green, gray, and transparent. And then, the beam profile was used to acquire profiles of the beams in 2-dimensional and 3-dimensional perspective. Statistical analyses were tested for normal distribution and performed one-way ANOVA followed by Tukey's test. The mean thickness of the acrylic was 3 mm, with the highest being 3.5 of the gray lid. The mean power light emitted from the post-curing unit was 445.6 mW with 1.7 deviation. The LCU positioned 2.9 mm from the intergetting sphere had no statistical difference than with the interposition of the transparent acrylic. The residual light transmitted to the yellow, green, and orange lids had no statistical difference between them, having residual light transmitter of 0.1 to 0.2% when compared to the control 0 mm group, with the mean value of 1 mW or below. However, the mean power transmitted through the gray and red lids were of mean value of 52 mW, having the residual light 11.7% and 11.8%, 18 times the value of the residual light transmitted throughout the yellow lid. This is the graphic of emission spectrum of the light emitted by the LED and attenuated by the barriers tested, which shows that the peak of the light spectrum is 405 nanometer. Notice that the gray and red groups have very similar spectrum, which were more attenuated than the green, orange, and yellow acrylic lids, that reach almost no light detected. The beam profile results show the inhomogeneous distribution of the light emitted by the LED, with the peak of the light concentrated in a small central area. Light attenuation was observed for all acrylic lids. No detectable UV light was observed when using yellow, green, and orange acrylic lids. A small amount of UV light was detected throughout the gray and red lids. The use of the acrylic lids blocked significantly the UV light emitted by the post-curing unit. but the color of the tested 3D printer acrylic lid significantly influenced the photoprotective capacity against UV light emitted by the LCU, with the yellow, green, and orange with superior efficiency than the gray and red. The post-current unit UV radiation ranges between 380 to 430 nanometer, with peak at 405. The LED units have higher light spectrum in the center as shown in the beam profile. The damages of UV radiation are cumulative and dependent on intensity, duration, and interval between exposures. That being said, even if a numerically small percentage of the total emitted light passes through the red and gray 3D printer and UV lids, continuous exposure can cause numerous harms to the human body, and the less effective photoprotective color lids contributes to this hazard. In conclusion, the LED presented in the post-current unit emitted power light of 545.6 mW with 1.7 deviation, with the peak intensity at 405 nanometer. All 3D printer acrylic lids blocked significantly UV light. However, the color of the acrylic lids had a significant impact on the UV light attenuation, with green, orange, and yellow lids significantly attenuating more UV light than the gray and red acrylic lids. The occupational exposure to UV radiation is a daily reality for professionals who work with additive manufacturing. This is a reality in many fields of knowledge. For this reason, anti-UV lids must be made from a color with high photoprotective efficiency to ensure a safer working environment. And this concludes my presentation. The authors would like to acknowledge the collaboration of CPBio, the School of Dentistry at the Federal University of Uberlândia, CAPES, CNPq, to the FAPEMIG, and to NCT Oral Health and Dentistry. These are the references used in the study. Thank you so much for your attention.